Okay, so this is Richmond, and today we are on differentiation, and then today we want to talk about the product rule, and we talk about the quotient rule, and then we also talk about how we can differentiate a function and a function. So this is basically what I come to do today. And on the board you can see that y is equal to uv, and then I'm saying that if x is mapping to x plus change of small increment in x, and then u is equal to u plus change in small u here, and then v is equal to v plus change in v. So as a result, I can also say that y maps to y plus small increment in y. So with this then, if I have y is equal to uv, then if there is some small increment in the y, I can say that then my y be turned to y plus change in small y. So I know that my y is equal to uv. So if there's a small change in the y, go to y plus y change in y. So it changes everything here. Then I'll have my u now changing to become u plus change in u. Multiplying my v also change to be v plus small change in v, like this. Alright, so now I can say that my y plus change in y is equal to u plus change in u multiplying v plus change in v. Okay, so now that's what I have. So with this, I just have to expand this expression, and I have my y plus change in y. All that I'm doing, that we want to prove the product rule. Okay, so we all know the product rule, but we don't know, some people don't know how to prove it, so we want to learn how to prove the product rule. So now y plus change in y is equal to, let me expand this one, u will multiply v and I'll get uv. U will multiply change in v and I'll get plus u change in v. And then this change in u will multiply v and I have plus change in u v, and then plus change in u will multiply change in v here, and I have change in u and then change in v. They are multiplying. All that we need to know is that here I can say that y is equal to uv here. All that we know is that this y has now been increased, and I now have y plus change in y, and this uv is now having increment, and then u has changed to u plus change in u, and v has changed to v plus change in v. Okay, so all that we want to do is that let's subtract y from y plus change in y and subtract uv from the whole of this expression. Okay, so all that we're going to do, so you subtract y from y plus change in y, we are going to get y plus change in y minus y is equal to uv plus u changes v plus change of u multiplied by v plus change of u and then change in v here minus uv. Okay, so let me just bring it here, minus uv, something like this. So the uv will cancel the uv here, and then negative y will cancel positive y here. So now if you left it, change in y is equal to u change in v plus change in uv plus change in u change in v, like this. Okay, so all that we need to do here is that divide both sides of this equation by change in x. So divide this one by small increment in x, this by small increment in x, this by small increment in x, and this one by small increment in x. Okay, so this is what we do. So at this point, we say that as change x approaches 0, as change of x here approaches 0, then my change of y over change of x now maps to dy over dx. and then my change of v over change of x now becoming dv over the x, and then change of u over the x also become du over the x, like this. Okay, so all that we want to understand here is that whenever we allow the small increment to be equal to 0, then we have the differential equation, or you have the gradient function, that is dy over the x. Okay, so here we can now say that our equation here is now becoming dy over the x is now equal to, and then we know that change in v over change in x can now become dv over the x. So I have equal to u dv over the x. And then here, the change of u multiplied by v has now become plus v du over the x, because here we have the change in u here, and the change in u over change in x become du over the x, and then plus here we have change in u and then change in v here, so the change in v becomes change in u dv over the x. But this particular equation, let's allow change in u to approach 0. As change in u approach 0, our equation now becomes dy over the x equal to u dv over the x plus v du over the x plus 0, because this now has changed to 0, and multiply everything here becomes 0. So our dy dx is now equal to u dv over the x plus v du over the x, and this is what we call the product rule. So in the next tutorial, we'll be taking more questions on how we can apply this formula to solve questions. Thank you.